Did you turn off the rename themselves or do you care? Just unmute and start videos, I don't care. Hold on, I don't need to do anything to this mic because we said that earlier. Then I just need to share screen whenever they tell me what to share. Guarantee it's gonna be duplicate, don't you? Duplicate. Okay. It don't matter. No, it's recording now, so.
Is there any way to check that we're?
All right, I'm ready if you all are. A few announcements. Let's see. All conference attendees, please make sure you sign in at registration desk so that you'll receive training credit. Please download the conference app from the App Store for a detailed agenda. Search for and download the Crowd Compass Events app. In the Crown Compass Events app, search for 2021 ACEC KY/FHWA/KYTC Partnering Conference. The password for the app is partnering 2021, all lowercase. For assistance with the conference app, please go to the conference registration desk. The preferred method of session evaluations is through the app. Your name will be downloaded from the app once for each evaluation you submit and placed in the collection for the drawings. You will be entered in Wednesday night's drawing once for each evaluation you fill out. Please fill out one evaluation per breakout session. Participants will be allowed to win only one raffle prize. If your name is called again, you may claim the second prize, but you must return your first prize. Your first prize will then be raffled again. Wednesday's lunch will be from 11:30 until 1 in Grand Ballrooms A and B. And Wednesday night's reception will be from 4:45 until 7 in Grand Ballrooms A and B. The reception will include the vendor hall, prize raffle, snacks, and cash bar. The green drink ticket located inside your badge will be honored at Wednesday night's reception. And then for our session today, we have crash data analysis tool demo and training presented by Paul Ross and Eric Green. Paul Ross works in research and IT, where he supports the technology for KTC and partners on a number of the center's transportation research projects. He has experience in video and multimedia applications that are used in marketing and communications. He was the 2016 keynote speaker for the Kentucky Association of Government Communicators on the topic of video production and has won multiple KAGC awards. Paul holds a master's degree in information communication technology and a bachelor's degree in psychology, both from the University of Kentucky. Now, Eric Green has his PhD in civil engineering from the University of Kentucky. He is the program manager of traffic and safety at the Kentucky Transportation Center and adjunct facility with the Department of Civil Engineering at UK. He is a licensed professional engineer in the state of Kentucky and has a geographic information systems professional certification and is a roadway safety professional.
Good morning, everybody. Thank you for attending today, and we appreciate it, especially at the 8 o'clock slot, those of you that put the breakfast down and join us here bright and early. So hopefully there's a lot of really great stuff that we're going to get to talk about today. Maybe a quick show of hands. Has anybody used, we'll call it CDAP, anybody used CDAP before? Has anybody not used it but heard of it? And who's just brand new to the tool altogether? Okay, so pretty even spread across the room. Unfortunately, we don't get that same participation from the folks online, but it's about a third here in the room with us today. So I guess maybe we can get started, Eric, with just a high-level overview of the tool itself.
Yeah, sounds great. Morning, everyone. And this isn't going to be a PowerPoint. We're doing live demo, so expect anything. Internet seems to be great. We might have a little bit of slowdowns with the demo, but we'll kind of talk through some of the features to it. So CDAP, just in general, is a tool that we built for the Kentucky Transportation Center, or for the Transportation Cabinet and their partners in highway safety. And basically, the original idea was to give access to crash data and roadway data. But we realized quickly that we also needed to add a component analysis. So using methods in the highway safety manual, we built a tool that folks can use to analyze a section of roadway and basically develop a safety score with it that is pretty statistically robust. You can do it in two ways. Either import your own file that has a list of segments or query a specific mark range.
So part of data access is, of course, having appropriate access to data as well. While there is a public-facing portal that has a lot of summary data, oftentimes crash reports contain sensitive information, and maybe it's accidentally spelled out of the narrative, or maybe it may be personally identifiable. And so there is a process to get appropriate access to CDAT. That process involves one, reaching out to Jared Stanley and getting signed the MOU, and then two, having, I guess, a valid, in our case, research reason for access to the data, but also maybe a valid analysis reason for access to the data. And then CDAT includes various levels of access. Did you want to speak to that?
Yeah, and we have 3 different user levels, and Jared from the Transportation Cabinet will tell us what level of access the potential user has. And it's everything from basic access, where you can't see people's names and read the narratives, to an advanced access where you do have access to those, and then a higher level that we'll use internally to administrate the members and add people. So basically, you ask for access, you sign an MOU, then you're given access to the tool at one of those levels.
And it's worth noting that there are logs on the tool. So at any point, what's being done with the tool can be audited. So there's some accountability that's built into the system. Now, this is the second year of development on this project. And the first year we really got it off the ground, and then we ran a panel to see what do you like, what could use improvement, what are some opportunities. Eric, do you want to discuss a few of the enhancements this year, folks that maybe in year 2 of their use with CDAT?
Certainly. I will point out before I get to the query tool, there are some helpful videos posted on the site, even before you log in, where you can look at the basic overview of the tool or details about the query tool or the import tool. We're not going to talk about the import tool this session because we covered it last year, and not much has changed to that. The real enhancements we made was to the query tool, and that's a tool where you plug in your mile point ranges for a given county and route, and it allows you to analyze that specific segment. And at kind of a high level, some of the things we added were maps in two forms. We added a map to allow the user to query a segment of road by clicking on a map. You may not be as familiar with the county route and mile point that you're looking for, but you know where it is on the map. So as long as you're able to click on it and zoom to it, the tool will set to those mile points. The other thing that we added was the intersections module. So if you click a segment that has one or more intersections in that segment, we split those out separately. We define intersections by a polygon around all of the approaches on an intersection, and they get treated a little bit differently than segments. Yeah, you don't have a length component when you're analyzing intersections. So we pull those out in a separate table, and you're able to look at those intersection safety scores separately from the segment safety score. And then again, at the high level, the last thing we added was a map for displaying the roadway crash data once you pick this segment. So, and Paul, feel free to chime in at any point as we're going through here. But the basic selection piece of the tool is the drop down for the county, all of the available prefix, route prefixes in that county, and then a drop down of all those routes. So if you really are looking for a specific route and you know the prefix, you can drill down to it by clicking the radio buttons here. Generally speaking, we're just looking at the main line, which that means that the primary segment of the route. You can also look at ramps, and that gets in a little more details. A A lot of times we don't have as much roadway information on a ramp, particularly traffic volumes. So that type of analysis might not be as sophisticated as a main line route. So Adair County has Kentucky 55. It's numerically the first one that pops up, and it runs from 0 to a little over 21 miles. And this is kind of the default the tool loads. So this has been the most analyzed route in the state. And that's obviously because when we test the tool, this is the first one that pops up. So I'll just show you kind of a little bit about this segment, even though this is not a segment you would normally analyze because it starts at the county line at one end and ends at the county line at the other. You wouldn't analyze this segment as a whole. The tool is really going to encourage you to shrink it down to a more homogeneous segment. You want the roadway to be very, very similar from start to end. And again, intersections will be pulled out. We did add a what we call a segment table that at the high level, it shows from 0 to 21, it shows any changes in lane widths, number of lanes, traffic volumes, rural, urban, and things of that nature. We are working on updating this table with new data, and it's going to pull out some of these mistakes that we have in here. We've got some 0 mile segments that had just some bad data in it. So it's flipping back and forth between different types of roadway data. But this is all fed from the cabinet's HIS data. So this tells us about the roadway geometrics of the segment. This is what we want to be homogeneous. So then we next get to the map. And this was a huge addition for this year. And it really enables folks to visualize the segment that they're looking at. So again, it would be ridiculous to analyze this segment as one piece because obviously it's changing. It doesn't necessarily go into an urban area, but it gets pretty close, and it's very different at the tail end of the route versus somewhere in the middle. So as I said, you can click on the map and interact with it. If you select a route on the map, you have an option where it's temporarily highlighted. And if you scroll down below the map, it'll tell you this is Kentucky 2287, starting at 0, going to 1.8. And then where you clicked along the segment is shown by something called XMP. That just tells you roughly what the mile point is where you made the click. What's interesting here is it shows you a little bit about the nature of this route in that it actually has a junction disjunction where this route stops when it gets to this main route here, and the mile points go on hold and then pick up later here. And that adds another level of complication to any kind of analysis. So generally speaking, you might want to analyze just the northern and the southern pieces of this route. If you wanted to switch to this route, it's temporarily highlighted in a thinner line right here. You would just click the button here and it would change it either to 0 to 1.8, or if you click the bottom below, it'll pick a segment around where you clicked just by adding a little mile points before and after. So either option there, and basically it will change it up here on the top, and the table will update and the map will update. But until you click one of these buttons, it's still going to stick with what you picked to begin with. So we're not going to go into huge detail about all of the results in here, because again, we covered it last year, but just kind of in summary, you can choose the severity type that you want to focus on. You can filter it by some very, very high level filters. You do not want to generally pick more than one of these because they are ands, or they're ors in this case, where you don't want to look for anything that is, lane departure and distracted driving, because you're really going to filter down to something that you're going to get very, very few crashes. It's highly unlikely you have a motorcycle and a commercial vehicle. So make that clear. It is an and query, so it's going to do both of them. So that was really set up so that we could do emphasis areas if you're looking at a specific type of crash. So use with caution. Generally speaking, we look at public roads and ignore private property. And generally speaking, we look at crashes that didn't occur on a parking lot. A parking lot crash still can have a route and a mile point. just because that might be the closest thing the officer found to the parking lot. But if it is a parking lot crash, it'll be tagged as such, and you can eliminate those.
On the bottom there, it's worth highlighting. We have a 5-year table or 5 years worth of data. We're about to load in the 2020 data here, probably within the next week or two. And this is a snapshot. It's not like the TED database. We've actually named it the Bill database. So if you're fans of Bill and Ted's Excellent Adventures, funds are nested deep within some of the development. But it just works out better to have that snapshot so that as you're doing analysis, you can go back and replicate what what you're showing instead of having something that's sort of always a moving target. And that's one of the value statements of this tool versus some of the things that may already exist elsewhere.
Yeah, and that's a fair point. When we add the 2020 data, we're also going to update the HIS data so that we can fix some of the issues that we found in that table. But yeah, as Paul says, we will update this tool once a year with the data. So again, it's not that moving target. If you do this analysis this month versus 4 months from now, you're going to get the same numbers, and that's a good thing in our context. If you need live crash data, you can probably use a tool like Hy-Vee, the Trend Tracing Cabinet maintains. So once you hit the View Data button, you get roadway data, crash data, and intersection data. And there, for each of them, there's an option to show the table. So here we're looking at HIS data. So this is roadway data for this 21-mile segment of road. It's all 2 lanes. It goes from 10 to 12-foot lanes. It varies in shoulder widths. There's a little bit of curvature, horizontal curvature there. Again, it's popping up here. It's always a rural classification. And then there are some parts that have a flush median, even though it is a 2-lane road. It's something we sometimes mistake. Again, I'm not going to get into huge details here. You can click on the titles to look at more details of those parameters, but that's something we covered last year in great detail. I really want to kind of focus on some of the newer pieces. But if you do have questions, feel free to pause me, and I'm happy to answer them, as this is a live demo here. So the next newest piece we added was the intersection module. So anything that's tagged as an intersection crash, as defined by a crash that occurred within the polygon that we've defined in our intersection database. And that's probably fair to point out that that is distinct from the police officer's code for an intersection, which we've found sometimes includes intersection-like features, like a driveway or some other feature like that, as a safety professional, we don't really consider that an intersection. So there's that distinction there. And we found it was a bit easier to look at spatial analysis to decide where intersection crashes are. So all of the intersection are treated as a single entity with entering ADT and all the crashes on the main line and on the approaches. So that's what this module is aiming to show. There were 54 crashes that happened on the route that you selected that were also part of an intersection. And you could show that table by clicking this button, but since I can't guarantee everyone here has had a signed MOU, you can just click the button because you might see some data that you aren't authorized to see. You also have an option to download the data as a CSV. Again, as Paul said, that's logged, and that's just something we're going to monitor to make sure people aren't misusing those extracts. You don't want to just zoom to your house and do a crash analysis around your house if it's not based on a project you're working on for the cabinet. It may be fair to underscore the importance of us focusing on the security. The cabinet came dangerously close to losing access to crash data years ago because of just misuse of data and maybe more misunderstanding of the importance of it. We have everything from folks printing off police reports and handing them to people, and even talk with people trying to share that data with insurance agencies. So we take it very seriously now and make sure that anyone who has access to this tool or the crash data in a research capacity uses it for that research and nothing else. As I said, and like all of the crash modules here, you can look at the different types of crashes. So roadway data, weather data, things like that for these 54 crashes. Those are at the segment level. They're intersection crashes that happen on the segment that you picked. Down below is the intersection table. This includes every intersection that's within that segment. Also, all of the side road crashes. So if you have an intersection on Kentucky 55 and there are crashes that were on the side road, those are going to be shown in this table. And you can see the major and minor ADTs here, and you can see a variety of information about that. And one of the things that we feel is important here is something we call EEC, and that is our safety score we're associating with this, this intersection. So looking at the ADT, looking at the number of crashes, looking at what would be expected for this type of intersection, we're able to score that with a negative or a positive number indicating the safety of that segment. So this is typically something we sort descending, and the ones at the highest EECs would be the ones you would want to prioritize for any kind of improvement. Okay, the last big piece that was added to this tool is what we call the advanced map. So this is now that you've already picked your route and your mile points, you're now able to see a map that shows all the crashes, and they're color coded by severity. And then, apologies, I know that people on Zoom won't see this floating screen. You guys get to see it. We also have layers showing you HIS data and a aerial image if you want to turn on. And then something we call EEC layers, which is basically a scoring for all of the segments in the state that was done statewide that you can use to kind of compare the segment you're looking at to nearby segments. So I'll get into more detail on this map when we get down to a smaller segment, but I wanted to show it kind of high level here. The last piece down here is the same we saw for intersections for the segment. So these are the 96 crashes that are plotted. Again, you can show the table of download. You've got your charts and graphs you can look at here, and that just shows you what types of crashes are occurring. If you're looking for something specific or you think a certain type of crash is overrepresented, you can look here. And the nice thing about this placement here is it's right next door to a set of charts and graphs for similar roads. So anything that's like Kentucky 55 from 0 to 21 is shown here. Now this is where we get into that homogeneity question. What we're looking at right now is a variety of lane width, shoulder width, and median types in curvature. We want to get that shrunk down to a more homogeneous type of geometry. Right now, the radial buttons that are selected are indicating the most prominent of all these. And that prominence might not be the same pavement. You know, we might have the most miles of 12-foot lanes and most miles of 4-foot shoulders, but they might not be coincident in all cases. So what you really want to do is zoom into that segment that is very, very similar from start to end. It can have a little bit of variation, that's okay, but it will affect what we call the segmentation score. Right now it's saying it's very poor. In fact, 0% of the segment is all similar. So 0% of it is two lanes, 12-foot lanes, 4-foot shoulders, no median, rural, with no curvature. So as we shrink down the mile points, you'll see how that score will go up, and things will get a lot more homogeneous. The next step would be to detect your SPFs with a score of 0% and poor. I wouldn't even bother clicking that button. You're not going to get something that is going to be very reliable. So we're going to go back to the top. Paul, what do you recommend?
So let's shrink it down to maybe 0 to 5.
And anytime you change the location information on the form here, the page will have to reload, and all of the pages that you opened up will go away. And it's asking to kind of start over from the top going down. Okay, so 0 to 5. Okay, now we're looking at basically one change in ADT. Other than that, it's very similar. 2 lanes, 10-foot lanes. So, and then you can see on the map, it's starting here at the county line and ending here. We do have some curvature here. Things like that can generally be okay, but we'll look at our segmentation score and try to decide from there if we need to trim it down anymore. So I'll just move forward and keep everything the same. Beta. And below. I think looking at the map, I think curvature is going to be one of our next pieces to maybe consider filtering out. Apologize for slowness here. It seems to kind of come up and down sometimes. 20-mile segment seems to go faster than 5-mile segment at this point. Any questions while we're waiting for things to churn? If I go over to something too fast. Okay. Were they out of coffee this morning? All right, here we go. Again, you see the roadway data. Now the graphs that we're seeing are, there's less variation. Again, you see that curvature here in the curve class. Intersections within there, 4 of them. Look at the map here, and it shows you the crashes on the map. And again, symbolized by severity. And here I'll get into a little more detail about the map itself and what you can see within it. So we've got kind of the dotted line showing us the segment that we're looking at. And the point of that is that we can turn on, if you wanted to look at ADT, you could turn on these ADT bands that, generally speaking, we're in the lowest category of 0 to 5,000. So pretty much everything around here is green. And you can go to other the data loads in anywhere in the state. You can see how it'll vary in different areas. But generally speaking, we're looking at pretty similar ADTs here. If you were looking at a specific point and you wanted to turn on the imagery, you can turn on the imagery service. And again, we're just trying to use like a dotted line to represent the segment that you picked. So you can see that. There is the EEC layer. Now this one gets a little complicated. We've got a lot of information in it. It's pointing to a service that the cabinet has provided. And it's part of the Highway Safety Improvement group and Mike Vaughn's kind of his layer that he's had created by the GIS group. I think we're making some changes to it, and as the changes are made to the service, they'll actually just be propagated into this tool. All this tool is just pointing to that service. So right now it has a lot of info here. I think we're going to shrink this down to where it's only going to show either EEC bands or LOS bands. They're telling us the same thing, right? So if you're looking for a positive or negative EEC, it would also give you the same indication of the level of safety as a service, LOSS, in the 4 categories. And we're not going to get into the details of these, but suffice to say that we'll have basically 4 different categories of safety. 2 are below 0 and 2 are above 0. And again, it's those high positive numbers are the ones that we would want to focus on. And we can look at that in 2 different severity levels, either K, A, and B crashes, or C and L. And that just gets into the more severe crashes and less severe crashes. And this really comes down to sample size. If you're looking at C and O crashes, you're having a lot more crashes, but they're not resulting in a major injury or death. Whereas if you look at K's, A's, and B's, thankfully we have a lower sample size, but also also we've got a more severe crash. So again, these will change based on when the services change. But I think the other thing beneficial here is that you can look at different chaff sections that some of you may be familiar with. You can look at congestion information, and then any kind of like boundary information you might have here as well. So I'll turn one of these on just so you can kind of see. Oh yeah, they also include intersection as well. So you can turn a variety of these. Probably won't need the urban ones. And what's happening here is that we're looking at EECs for a certain type of case, and that might not be what we're zoomed into. I'm going to turn on both of these. So one or the other. I might be a little impatient here for the service. Oh, okay, yeah. So it's shown here. It's just kind of subtle. So you can see by looking at the legend, you've got yellow, you've got green, and as you zoom in, you can see this is the intersection and how it's coded. So you can use this as a way to compare your segment's EEC to what's surrounding. Again, then you see the crash data at the segment. So we have the 11 crashes from mile marker 0 to 5, and we can see information about it. And you can also compare it to similar segments across the state. Now our radio buttons here are have less variation, which is a good sign. So now we could use these geometry parameters to pick what's called an SPF, safety performance function. A 2-lane, 10-foot lanes, 4-foot shoulders, no median, no curvature in a rural area. We'll have a matching SPF that will work for that. So if you drill down to a segment that really has this type of geometry, you can then move on to the SPF analysis. And being that it is a very homogeneous segment, we're likely to get a good safety analysis for this. This right here is the rural 2-lane SPF model that is developed, and this is another thing, as Paul said, that will be updated once a year and put into the tool. By the way, I didn't point out we're a segmentation score of 65%, which is saying okay. That has to do with curvature. Sometimes this might not be a problem, but if you have a section of road where the curvature is really driving the crashes, you may want to filter those out, or we'll break them up into smaller pieces. Here we have 11 crashes. We have something called an over dispersion parameter, which is tied to the model that we chose. We have a 5-mile length. We've got a length-weighted ADT of about 1,000. And then we have parameters A and B that came from that rural 2-lane SPF model. The nice thing about this tool is you don't have to understand all of the intricacies of the highway safety manual piece here, the over dispersion and these parameters, but you still get the luxury of using them in the analysis. So this is kind of, if any of you are familiar with critical rate analysis, or crash rates, or things of that nature, that used to be how we rated safety in this context. It's very similar, but a lot more sophisticated. And I think because of this tool, it's not nearly as complicated as it was many years ago. Okay, I click the last button, which performs the advanced analysis. This is when you are confident that you have the right model, you have the right severity group. You can actually make changes to these parameters here if you knew there were 14 crashes instead of 11, just because of data issues that they plotted in the wrong spot. You can change them here and it will affect the numbers, but it will flag that field. So if you run a report or print this out, it will tell whoever you share it with, hey, somebody went in here and changed the numbers. And that's really just to show that you change it from the defaults. Well, here we have the safety score. So we have a prediction of 17.7 crashes at the site. We've got some other parameters here, but the one I talked about the most is the EEC. This is a -4, almost -5. EEC. That's the safety score you can assign to this. It's below 0. So that gives you an indication that it might be performing better than expected. If you had another segment of roadway that you were looking at that had a +5, then that would be the one you would prioritize over this. So really, you're just looking at the magnitude of the sign of the EDC. We get a couple other things here that kind of get to the confidence of this score. This has a standard deviation of 3. So basically what that means is that we are thinking it's around -5, but it could be as much as -8 or as low as -2. So it just gives you kind of an idea of where it might swing. And you can use that again as compared to others. You might have a much higher number with a tighter band. And that just tells you you're a little more confident in that one. Okay, so let's maybe shrink this down just a touch to see if we can eliminate some of the curvature. I don't think we'll be able to get it all. And again, you can use the map tool above to get at the mile points here, or you can just kind of take a guess. But I'm maybe just look at these few crashes here at the tail end of the segment. So you scroll up to the top. In fact, if I wanted to, I could click here on the map. Careful where you click. Yeah, so that XMP I was telling you about is 3.2. So I could change this query to 3, let's say. And that should give us that. I don't see I did that backwards. I'll watch. And anytime you do change this, it does have to refresh. Be patient with it. If you change the beginning mile point, you gotta wait. So I want to go 3.3 to 5. Okay, and that kind of covered 2 segments here. And it may be more realistic to say 3.379. Now we eliminate this 704 traffic point, because that's just a fraction of the piece. Now it is a length weighted ADT calculation. So if we use the 704, we're only going to use a 100th of a mile of it in the overall average. But I'll just go ahead and click on this segment here, and that'll actually set us specifically to that segment here on the map. Through.
One thing I found when you're navigating on the tool with the addition of the maps, because the maps are interactive, if you use it on a laptop or if you're using the scroll wheel on your mouse, if the cursor of the mouse happens to be over the map, when you get to the map, it tends to change the extent. So if you're using the tool, use that padded area there on the right-hand side when you're scrubbing up and down the tool. That way you don't accidentally just zoom the extent in once you get the map portion of the screen.
That's a great point, Paul, and that's purposely why there's that white space there at the end. So that's a great spot to just keep your mouse cursor as you move up and down. Okay. Paul, I think that's something I just do subconsciously now and didn't even mention it. Okay, so the roadway data shown here, very, very small pieces of curvature. Now, see, we're over 2.5 miles of A curvature and just fractions of B's and C's. Here are the intersections. Here are where the crashes occurred and the severity of them. Similar segments. Again, we're looking at 2, 10, 4-foot shoulders. Now our segmentation score is 89%. It's really, really good. I can see that saying it's great. So we can detect SPFs. See, now it decides to be real peppy, real quick. We'll roll 2-lane, just the 3 crashes. There's our over dispersion, and we'll do our advanced analysis here. And we now have a EEC of -8, plus or minus of about 2. So still in the same LLSS ranking of 2. We're negative, we're low. We have a pretty tight standard deviation, which is a good sign, shows confidence. Generally, this tells me that the curvature on the first model didn't really hurt it. This would be something I'd be confident with, and this is a great way to rank that segment. So the next thing I had in mind was to really show you the kind of the importance of that segmentation. I think we covered this last time, but with the new tools, I think it might help emphasize a point here. Let me go to Fayette County. And points picked out here. So this is actually something that a consultant using this tool for a transportation cabinet project identified and brought to my attention. So something seemed really odd here. It was a great example of why we need that segmentation score and how it can help in your analysis. So what the consultant did was looked at US 27, mile marker 0 to 9.45. Again, if there are questions, comments, please throw them up. Anytime you see that loading window, it's a great time to get them out there.
We expect this will actually speed up as well. We're working right now on the back end. This has a SQL Server back end. We're actually moving the SQL Server off of virtual machine and onto a dedicated piece of hardware. So I think that's going to really speed things up. Probably as part of the adding the data that we talked about earlier.
Oh, 25. Oops. I'll say this map does not look like what I was planning to show. So change it to US 27. Change the mile markers to 0.945. Okay, this is more than I'm expecting to see. So you can see we've got 3 different segments here. Lane width, number of lanes are changing, ADT staying the same. Right here south of Fayette Mall, this segment here, okay, Nicholsville Road, if you're familiar with Lexington, just south of Fayette Mall here. That's our segment that we're gonna look at, and I'm gonna crank through the down to the segmentation score to take a look at what that looks like and then get the EEC for you. So you can kind of see, and I believe this came out by, the segment was in a CSV file from 0 to 9.45, or excuse me, 0.945. And it was imported in, and the researcher got the EEC back from it and was sticker shock. So wait a second, this does not seem like what I expect. So and keep in mind, that's the difference between the import tool, where you just blindly upload a bunch of segments to get the results, versus the query tool, where you're actually able to kind of go through the page and slowly, carefully check to see that everything makes sense. Okay, so lots of crashes happening here. And I'm going to just kind of highlight the fact that we've got a variety of median types, a variety of number of lanes, lane widths, shoulder widths, but otherwise the same. Or 0% segmentation score. Are we 5 minutes? And I'm going to give you the EEC for this, which is, so I found a model for this, and I had to choose between either a divided multi-lane facility or an undivided. And I picked one, and it gave us a very, very low score of EEC of -43. Right? So this is something you tell, well, no problem here. Let's move on to the next project. This guy's safe. Okay, it picked urban multi-lane undivided. Let's just take a look and, forgive me, I don't remember exactly where the change is precisely, but I'm gonna go about the first half of it, 0.0 to 0.45. And if you scroll down this one, we're gonna look at the segmentation score, and then we're gonna look at the EC and see what the difference is. So again, really the distinction here is we've got an undivided piece and a divided piece. And one has very, very wide shoulders, one has narrow shoulders, and then we've got a variety of the number of lanes. And if you're familiar with that section of road, this may be. Is that server upgrade coming? Oh.
Not soon enough.
Okay, so here we go. There are the crashes. And again, you can get into the weeds of the types of crashes that are happening. But now we're looking at an 80% of great segmentation score. Everything I plugged in has no median. Okay, that's good. So when we get to detect SPFs, what models are going to use? Multi-lane. Undivided. There we go. Crashes from advanced analysis. We have an EEC of -14. So it was -43. Okay. Now, the way this analysis works, it's not -14 and -43, get the difference, and that's what the other segment's going to be, because it's using an entirely different model. It has a different dispersion parameter. It has different parameters. So this segment is -14, a good segmentation score. No problem. Let's now go to, refresh the page, 0.45 to 0.945. Okay, the second half, so to speak, the second portion of that route, we're looking at more lanes. Let's put it up here. This is the divided portion of the segment. We've got more lanes. I think this is where maybe where we have the more narrow shoulders, but either way, the segment's very, very consistent. And now, yeah, in theory, it's going to find the segmentation score to match to a divided facility. Get that PowerPoint slides of all these, just in case it was really, really slow. We should be honest, this is, I mean, seems slow when everyone's staring at it, but I mean, it's actually doing quite a bit, hitting a lot of databases, merging the data, so. Okay, scrolling down, you can see the crashes. And again, you might look at the crash distributions of that. All right, it's still showing us with a poor score. And that's because it's not matching exactly with the number of lanes, exactly with the lane widths. And then there is a change with 1 and 10-foot shoulders. And then it's raised or flush. Now, don't let this alarm you. This is really just a caution saying, hey, something's different here. But the important thing is, as an engineer and as a roadway professional, safety professional, use your judgment to say, yeah, it's changing, but it's okay. I understand why it's changing. The difference between raised and flush here might not make a difference in the model. It's picking a multi-lane divided model, which has very different parameters than the other case. So when you click this button here and you look at the score, you're going to see a positive 55. So we went exactly the opposite direction of 0 from that 47. And this is exactly what the engineer had the intuition of. They said, there's something bad about this segment. So if you put the whole segment in there, you get a really, really low EEC, meaning safety, meaning safe. If you cut it in pieces correctly, you get at the answer that really is what you're trying to help find and prioritize. Dr. Solera?
Can a person use this wrongly by chopping things up until they try to solve the problem they wanted to say.
Yes, but the output of it should show that segmentation score. And unless they redact it. So don't trust anyone's data unless it's got that segmentation score with it. But yeah, you could, I mean, just like you can lie with charts and graphs, you can definitely lie with this. Question?
Did you see the question? Is there any report, use guide,
Any report or,
use guide?
oh, yeah. So there are two reports now on the website. One from the previous year and then an updated one with all the new features. And then there are 4 or 5 videos now that walk you through the features. And I suppose this is going to be reported too, so.
Yeah, and those will be loaded into the page that hosts the tools. So if you visit crashtool.uky.edu, those resources will be made available. There's also within the tool, we didn't really cover this, but within the tool, there's some links to help with definitions on certain things. So if you have questions about what do these terms mean, or I think there's some links to what MHWA resources. Sure.
I know we probably use it all the time, but Paul and I will stick around too if there are other questions and any housekeeping things. Okay. Well, thank you, everyone. Thank you, virtual guests.